The big question is, do you want a list or a dictionary? Here's a fun example that we can look at, or maybe it's not so easy to decide. So make a list of prime numbers. Let's go all the way up to 31. So 2, 3, 5, 7. I skip numbers like 9 that have divisors greater than 1, 11, 13, 17, 19, 23, 29, and 31. Okay, so go ahead and store that list. Now, lists have ordered, right? Dictionaries do not have orders. So they're very different in that sense. So this should definitely be a list. But I want to look at the indices of these. So how do I get the indices? Okay, so here's my list, and then it's dot index. And if I want to say, well, what's the index of the number 3? Well, it's 1. But if I want to know, like, what is the number that it is in the list, like 3 is the second prime, in effect, I want to add 1 to this. And this shows me, like, that 3 is the second prime. Okay, so kind of cool. So just to show you another example, if we jump down to another number, like 11, this shows me that 11 is the 5th prime. Let me just throw out one more. Let's go with 5. 5 is the 3rd prime. So if primes have prime indices, I mean, that's the index plus 1, then I say it's like perfectly prime. And we're going to make a new list of perfect primes. So if it's perfectly prime, it's these numbers. It's the numbers that, you know, like 3, because 3 is not the first, but the second. That's the first prime number. And so what we do is we basically count when we take all the prime indices, starting with 1. So 1, 2, we include 3. 3 is prime, so we include 5. 4 is not prime, we skip it. 5 is prime, we include 11. 6 is not prime, skip it. 7, because it's the 7th one, and 7 is prime, we take it. 8, 9, 10, 11, so 31 is prime. Perfectly prime, okay? And so this is fine to have as a list, but if they're perfectly prime because the original index is what matters, the question then is, if we're going to keep track of the index here, do we turn it into a dictionary or a list? Let's look at both. So first, let's look at it as a dictionary. Okay, so we'll call this a perfectly prime dictionary. All right, so how does this work? Well, what we need to do is we need to assign each of these a value. Okay, and we have the value. I'm going to go ahead and copy this in down here so we can see it. We have the value below. Okay, we can use both of these, right? So how can we populate our dictionary? So we'll call it perfectly prime dictionary, or dict for short, and it's empty right now. And so what do we want to do? Well, we want to go into the perfectly prime. So for it's called a number. No, it's prime. Let's call it a prime. So prime in perfectly prime. Okay. What are we going to do with it? Well, we're going to put it in our dictionary. It's a lot to sort of write it in. I think I'm going to just shorten it to prime dictionary. Okay, it's the only one we're working with. So for prime dictionary, and then we're going to put the prime in as the key, but what's the value? The value is the index plus 1, which we saw. So if I take this big list of primes, we know, remember the index of that prime, and I want to set it equal to, wait, that's what I want to set it equal to, sorry. I'm setting the dictionary equal to it. Okay, so let's go over this. Have a blank dictionary, it's empty. I'm going to populate it as follows. I go through my list of perfectly prime, right? That's these numbers. Now for each one of those, okay, what I do is I put it into my new dictionary and I assign it the value of the index plus 1, right? Not just the index plus 1. And then what we're going to do is we're going to look at the dictionary after we've populated it. Okay, so pretty cool. So what you can see here is 3 is the second prime, 5 is the third, 11 is the 5th, 17th is the 7th, and 31 is the 11th. Okay, and 31, for instance, it's kind of cool. Some of these are descending. 31 is the 11th prime, 11th is the 5th, 5th is the 3rd, and 3rd is the 2nd, where you have a sequence of primes going down here. Okay, so that's a dictionary. Now in dictionaries, the order doesn't matter, so you could also do this in a list. Okay, so how would you convert this, into a list? Well, it'd be very similar, right? Let's just copy it in and make some modifications. Okay, so instead of a dictionary, it's going to be a list. So let's change this to our prime list. And then we use these square brackets. Now we're still going to loop through our original list. And what we want to do here is we want to append instead of like adding, right? So how do we append? Well, prime list dot append. We're appending the prime number, okay? But we want to actually append it as a list. And we want the list to be both the prime number and this prime's index plus 1. Okay? So see, we have an empty list, and what we're doing is each time we loop through the perfectly primes, the 3, we're going to combine, we're going to add on not just the 3, but the 2 also in the form of a list. And at the end, then let's show what the prime list looks like. Okay? So press Shift Enter, and you can see it has the same sort of values as the same numbers, but it's in dictionary rather than, in list rather than dictionary form. Now, this is a close one, okay, meaning like should it be a list or a dictionary if this is the information that we want to capture. Now, if it's solely this information, you could have it as a dictionary, but, right, like 3 is the first of the perfect primes, and then 5, and then 11. So for order to be preserved, I would say a list is actually what you want here. And generally speaking, when order matters, use a list. You can use list inside of list, as you're seeing here. And really, I would just say that the complement, when order doesn't matter, use a dictionary. Dictionaries are faster, but they also have uniquely this key value idea. And so you also, of course, want to have a pair here. When order doesn't matter, use a dictionary. And I'll just add on with key value pairs, because it doesn't make sense for just one entry. You want 2 there.